Today we're going to be talking about strokes. Strokes are also called cerebral vascular accidents, or abbreviated CVA. It can be called brain attacks. A stroke is damage to the brain resulting in permanent neurologic deficit. This damage is done in two different ways. It can be done with hemorrhage, bleeding right into the brain tissue, or it can be done with ischemia, a lack of blood to a portion of the brain. In this video, I'm going to be talking mainly about the ischemic strokes. The ischemic strokes are caused by either an embolism or a thrombosis. We can't talk about the pathology of a stroke without talking about how blood clots, or talking about atherosclerosis and how those things affect the cerebral vessels. We have 150 to 400,000 platelets in a cubic millimeter of blood. That's a very tiny little drop of blood to have so many 150 to 400,000 platelets in it. In other words, our blood is full of platelets, and those platelets want to clot. So why don't these platelets clot up in the blood vessels? What is it that stops them from clotting? Well, the endothelial cells, which are the cells there on the inner lining of this blood vessel that's I just drew up there, they have antithrombotic chemicals that they release. And that makes the inner lining of the vessels antithrombogenic. But if you cut yourself and the platelets come in contact with the layers underneath the endothelial cells, they will clot to that. I drew the platelets here in green. See the little platelets all clotted up in that little section there that's supposed to be the damaged area of the endothelium. They are stuck there, but when the platelets are stuck, that's just a platelet plug. It's not a clot yet, and it's very weak, and it falls apart really easy. It's not a good strong clot until fibrin sets in there. So where does the fibrin come from? Well, fibrinogen is circulating around in the blood all the time. And what happens is, see that at the top there's the fibrinogen, and it has that little ball on the nose. What happens is thrombin makes it so it knocks that ball off the end of the nose, and it makes it so the fibrin can stick together. If you see at the bottom, without the ball, they fit real nice together, and they form these long strands. The long strands go into the platelet plug, and now instead of a platelet plug, you have a strong clot. Okay, now we need a balancing mechanism. Whenever we have something happening in the body, there's always something that's got to kind of counteract it, right? Something to keep the clotting under control, and also something to remove the clotting once we don't need it anymore. So what we have then is we have prostacyclin, nitric oxide, and plasmin, and a heparin-like molecule. So, and we have those things to get rid of the clots when we don't need them anymore, or to control the clot growth. Prostacyclin and nitric oxide all come from the endothelial cells, and they prevent platelet aggregation, so they stop new platelets from forming, and they stop existing platelets from growing. Remember, thrombin acts like an axe, chopping off that round portion on the end of the fibrinogen, causing fibrinogen to turn into fibrin, which can now stick together and form these long chains needed to reinforce the platelet plugs. So heparin acts like a shield, and it stops thrombin from getting to the fibrinogen. So the fibrinogen isn't converted to fibrin. So the So heparin slows the conversion of a weak platelet plug into a strong clot by impeding thrombin's action on fibrinogen. So far, we have talked about stopping the growth of clots or preventing clots from being formed. But what about the clots that have formed? We've got to have a way of stopping or getting rid of them, right? Of actually breaking them down. We haven't talked about that yet. Well, plasmin is the guy that breaks up clots. And how we get plasmin is we have plasminogen circulating in the blood all the time. It has to be activated from plasminogen to plasmin. And tissue plasminogen activator is the chemical that is released from the endothelial cells to do that. Tissue plasminogen activator, TPA, um, turns our plasminogen into plasmin. And plasmin eats fibrin. You eat fibrin, clots break up. In fact, we have a recombinant TPA that we use to treat MIs and stroke.